Hi, welcome to this Corbettmaths video. In this video, we're going to go through the video solutions to the Corbettmaths practice questions on views and elevations. So if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 354, there's a video tutorial there on views. Alternatively, you can scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, question number one. Question number one says the diagram shows a shape made of centimetre cubes. So we've got the shape and it's made from centimetre cubes. And we've been asked in part A to draw the front elevation of the shape. Now, I'm actually not going to scroll down any further here because I actually want to be able to draw this and see the shape at the same time. So probably if I was doing this, I'd actually probably move down a little bit in this grid, but I'm just going to stay here. Okay, so if we wanted to draw the front elevation, we're looking at it from this direction here. So what we would see is this shape here. It would go across like so, up, across and down. That's the front elevation. That's what we would see. So we would see along the bottom, we would see 1, 2, 3, and use a ruler here whenever you're on this, and then you would go up 3, 1, 2, 3, and then cross 2, 1, 2, down 1, across 1, and down. And that's the front elevation. If you were standing in front of the shape and looking at it, that's what you would see. Okay, part B. Part B says draw the side elevation. So the side elevation is either viewing it from this side or from this side. So in this question, we can draw either one. In terms of from this side here, I'm actually just going to rub out this here for the minute, the front elevation. Now, if we were standing here and we were looking at it from this way here, what you would see is, well, it would be 1, 2, 3 up. It would go across 1, 2 because the depth of the shape is 2 squares. It will go down 3 and across 2. So it'd be a rectangle. It would be a rectangle that goes 2 across and 3 up. So I'm going to draw the view from this side first of all. So it would look something like this. It would look like this. It would look like this, where you're going 2 across, 3 up, and 2 across, like so. So that's the side elevation from that side. If we were looking at the side elevation from this side, you'd see a similar shape. It would still go up, across, and down. But you may see actually that here it actually goes back a little bit. So whenever we're drawing a side elevation from this side and it goes back a little bit, what we would do is we would draw that outline, the 3 down, across, and up 3 and across. You might actually see a line across here just to show that it goes back a little bit. So it would look something like this. So it would look the same in terms of that rectangle. So I'm just going to write over here. But if you notice that whenever we go up 1, 2 rows, that third row is just a little bit further back. So what I'm going to do is I'm going to put a line across here. Sometimes that line could be dashed. I'm just going to do a line like that. So that's the side elevation. It would either look like that rectangle, or that rectangle there, depending on which side you're looking at. And if you drew either one of those, fantastic. Okay, let's look at our next question, question number 2. So question number 2 says the diagram shows a shape made from centimetre cubes. So we've got 1, 2, 3, 4 centimetre cubes joined together, and there's the front of the shape. And part A says draw the front elevation. So if we were at the front here and we were looking at the front elevation, well, it would be 2 down, and then across 3, up 1, across 2, up 1, and across 1. So it would look like that. That would be the front elevation. So let's draw that. It would go down 2, across 3, up 1, across 2, up 1 and across 1, and that would be the front elevation. Normally I would draw that a bit lower in the grid, but I'm just drawing it here so we can see the shape at the same time. Okay, part B. Part B says draw the plan view, so that's from above. So let's look at it from above. I'm just going to rub out that front elevation there. So from above, I'm just going to do it in blue. If we look down on it from above, what would we see? Well, we would see the shape here. So we would see it going across, and then you'd see it going across like so, up, across, across, like so. So it would be a rectangle, which is 1, 2, 3. Now they are in different levels, so you might actually see that it's a bit lower. You might sort of see a little bit of a line there. So you're going to have a rectangle that has 1, 2, 3 squares across with a line there. So the plan view from above will be a rectangle, and it would be 3 squares across, and we're going to draw a line here to show there's a change in height there. So it looks something like this. So 1 down, across 3, up 1, across 3, and then a line down there, just because that bit was a bit higher than that bit. And that's it, that's the plan view. Okay, let's look at our next question, question number 3. So question number 3 says the diagram shows a shape made of centimetre cubes. So it's made from centimetre cubes, and we've got the front view here. And part A says on the centimetre square grid, draw the front elevation. So we need to draw this front elevation. So I'm just actually going to sketch it here to begin with. So the front elevation, it would be down 3, across 3, up 1, across 2, back up 2, and across 1. So it'll be that shape there. So let's draw that as the front elevation. So it'd be down 3, across 3, up 1, across 2, up 2, and across 1. Obviously use a ruler and pencil whenever you're drawing these, but that's my little sketch of the front elevation there. Okay, and then part B says draw the plan view. So the plan view, so I'm just going to rub out that front elevation there. So the plan view from above, so I'm just going to change colour of ink 2 to red. So it would say if we were looking down from above, what would we see? We would see 3 squares, and then across 1, and then across another 2 like so, and then up 3, across 2, and across another 1. There's a change in height here, so it would be a square, it would be a 3 by 3 square. But here there's a change in height here. These 3 squares are higher than these ones. So it's going to be a square with a line there on that left hand side. So it would look something like this. So it would be a square, 1, 2, 3, across, up, and across. But then these 3 squares were higher, these cubes were higher than the other cubes, so we're going to draw a line like so. And that's what you'd see from above. You would see a square with a line going back like that. And let's just have a look. You'd have that square, and then we draw that line to show they're a different height than the ones below. And that's it. So we've drawn the front elevation and the plan view. And obviously use a ruler and pencil. Okay, let's look at our next question. So question number 4. So question number 4 says the shape below is made from centimetre cubes. So this shape's made from centimetre cubes. And we've got the front of the shape, that's the front elevation. And on the centimetre grid, we need to draw the front elevation. So let's have a look at what we would see. So it would go down, it would go across 4, it would go up 1, and then it would go across another 4. So it's going to be a 4 by 1 rectangle. So let's draw that. So it would be a 4 by 1 rectangle. It would look like this. It would go down 1, across 4, up 1, and across 4. And that would be the front elevation. Okay, then part B. Part B says draw the plan view. So what do we see from above? So I'm just going to rub that out and draw the plan view. So we're now looking at it from above. So if we're looking down on this shape from above, it would go across 4. It would go up 4 on the left hand side like so. And then it would go across, down, across, down, across, down, and across, down, a bit like a flight of stairs there. So we're going to say it's going to go across the bottom like so, and then it's going to go up 4, then across, down, across, down, across, down, and across, down. So let's draw that. And again, use a ruler and pencil whenever you're drawing these yourself, but it's going to go across 4 like so. It's again going to go up 4, 1, 2, 3, 4. Across 1, down 1, across 1, down 1, across 1, down 1, and across 1, down 1. And that would be the plan view. And let's just have a look at it. Yeah, that's the plan view. Okay, let's look at our next question. Okay, question number 5. So question number 5 says, here's the side elevation of a solid 3D shape. And so it looks like an equilateral triangle, or it's a triangle. I'm not sure if it's equilateral. I haven't measured the sides, but it looks like one, or it's a triangle anyway. And so circle the shape that it could be. And we've got 4 choices. We've got cylinder. Well, if you're looking at a cylinder, well, if it was standing upright like so, this is a bit of a bad sketch. If you're looking at the cylinder upright like so, and you're looking at it from the side, you would see a rectangle. It would look like a rectangle. And try it out. Get a can of beans, put it on a table, and look at it from the side, and you'll see a rectangle. Or if it's laying down, you know, if it's a cylinder and it's laying down like so, and you look at it from the side, you might see a circle, or from the other side you'd see a rectangle, but you wouldn't see a triangle anyway. So it's definitely not a cylinder. And try these out. Get some shapes and look at them from the side, and look at them from above, and so on. And you want to consider the side elevation. And obviously you remember that these 3D shapes can be in different orientations. They could be standing upright or laying down. But anyway, a cylinder would not have a triangle as a side elevation. Okay, sphere, a ball. Well, if you had a ball and you're looking at it from the side, what would you see? You would see a circle. So it's not going to be a sphere. A cone. Well, if you had a cone, so a cone, and you're looking at it from the side, you would see a triangle. So that's going to be the side elevation of a cone. So if you've got a cone, and again, try this out, get a cone, maybe an ice cream cone, put it upside down, and so it looks like this, or a traffic cone, and you put it like that, and look at it from the side, and you're going to see that triangular shape. So it would be a cone. And finally, a cuboid. If you were to get a cuboid, so if you do a little sketch of a cuboid, and you draw it from, just a little sketch of one, and you look at the side elevation, what would you see? Well, it could be a rectangle or a square, but it's not going to be a triangle, so it's not a cuboid, and that's it. So a cone, if you look at the cone for the side elevation, would be a triangle, and that's it. Okay, let's look at our next question, question number 6. Okay, so question number 6. So question number 6 says the diagram below shows a shape made from centimetre cubes. So this is made from centimetre cubes. And on the centimetre grid below, draw the elevation of the shape from P. So we need to look at the elevation from P, so what the view would look like from this point P. So if we were looking at it from the point P, what would we see? I'm just going to change colour of ink here to red, just because it's a little bit thicker. So it would be 1, 2 up, so it would be 2 up, across 1, down 1, across 1, and actually across another 1, and then down 1, and then across 1, and then across 2. So it'll be a bit of an L shape. And this part here, it actually goes a bit further back, so we're going to draw the line there. So we're going to draw this shape here. So it's going to have 1, 2 squares, and then another one here, and then one here, but with that line there. So let's draw that. So it's going to go, if we draw this left-hand side to begin with, it's going to go down 2. It's going to go across 2. It will go across another 1, but we're going to draw a line there because it goes further back. We're then going to go up and across, and then it's going to go across another 1, and then it's going to go up 1, and then it's going to go across 1, and then we're going to draw the line there because that bit was a bit further back, so we would see that shape there, and that's it. Okay, let's look at our next question. Okay, let's look at our next question, question number 7. So question number 7 says a solid is made from 1 centimeter cubes. So we've got these 1 centimeter cubes, and we've got the front view here. So this would be the front elevation, and we've been asked to draw the front elevation. So if we're standing here at the front, what would we see? Well, if we're standing here at the front, we're looking at it, what would we see? Well, we would see this square, this 2 by 2 square. We would see that. We would then say, if we were looking at it, we'd see that square, we'd see these 2 squares sticking up on the left hand side. So this little rectangle sticking up on the left hand side, you'd see those 2 squares sticking up. And then you would also see this shape here. So this shape on the right hand side. So it goes across 3, and then it goes up, and then across, and then down, and then across. So it would be 1, 2, 3 squares across, and then another 2 up. So what would we see if we were looking at it? We would see this square at the front. You would then see this rectangle sticking up, these 2 squares on the left hand side, and then you'd see these squares on the right hand side. It going 1, 2, 3 across, and then up 2. So let's draw that. So we would see the square on the left hand side, that 2 by 2 square. We'd see those 2 squares sticking up on the left hand side, and then we would see that shape that goes across 3 squares on the bottom. It then goes up, and then across, and then down, and then across, and it's 1, 2, 3, 1, 2, and that's what we would see. And this part, this 2 by 2 square, is in front of the other 2. That's why it's got those lines there, and that's it. That's what we would see. Okay, let's look at our next question, question number 8. Okay, let's look at our next question, question number 8. So question number 8 says, shown below is a cuboid. So we've got this cuboid, and the base of the cuboid is a 4 centimeter by 3 centimeter rectangle. The rectangle on the right hand side is 3 centimeters by 1.5 centimeters. The rectangle in the front would be 4 centimeters by 1.5 centimeters, and the top would be the same as the bottom, the left side would be the same as the right side, and the front would be the same as the back. And the question says, on the centimeter square grid below, draw the front elevation. So we want to draw the front elevation of this cuboid. So if we were looking at it from the front, it would go 4 centimeters across, and it would go, well, if it goes up 1.5, it's going to go up 1.5 there, so that would be 1.5. So the front elevation, if we were looking at it, would be this rectangle here. So this rectangle at the front there. I'm just going to get rid of this line at the back there. And so we'd see this rectangle, if we're looking at it from the front, it would be 4 centimeters across, 1.5 centimeters up, 4 across, and 1.5 down. So let's draw that. So it'll be 4 centimeters across, 1, 2, 3, 4, 1.5 up, so it'll be halfway between the first and the second square, going up there, and then across. And that would be the front elevation, 4 across and 1.5 up, and that rectangle, that's what you'd see if you look at the front elevation of that cuboid. Okay, and then on the centimeter grid below, draw the plan view. So the plan view is from above, so if we look at this from above, let's drop that out. If we look at this from above, what would we see? We would see 4 going across, 4 centimeters going across, and then it goes back 3 centimeters, across 4 centimeters, and back 3 centimeters. So it'd be a rectangle. If you look at this cuboid from above, it'd be a rectangle, and it would be a 4 centimeter by 3 centimeter rectangle. And we've got 4 centimeters at the bottom of it, 4 at the top, 3 on the right, and 3 on the left. So let's draw that. So 4 centimeters going across, 3 going up, 1, 2, 3, 4 going across, and 3 going down. So that's what we'd see. It'd be a 4 centimeter by 3 centimeter rectangle, and that's the plan view from above. So that's what you'd see if you look down on that cuboid, and that's it. Okay, let's look at our next question, question number 9. So question number 9 says, shown below is a solid shape made from centimeter cubes. So we've got these centimeter cubes. It looks like a capital T, and it says on the centimeter grid, draw the front elevation. So the front elevation. So the front elevation, it will go across 1 at the bottom, and then it goes up 2 on either side. It goes out 1 and out 1, up 1, up 1, and across 3. So it does look like that capital T shape. That's the front elevation. So let's draw that. So that's the front elevation. Okay, and then part B. Part B says to draw the plan view. So the plan view is from above. So let's draw up what we've done there, that front elevation. And let's draw the plan view from above. So the plan view is looking down at it from the top. So we'd see 3 along the bottom. We'd see it going up 2 and up 2 and then across 3. So it's going to be a 3 by 2 rectangle. So it's a rectangle. It's going 3 across, up 2 and then back 3 like so. So it's a 3 by 2 rectangle. So let's draw that. So the plan view would be, it would go down 2 and down 2. We've got this 3 centimeters at the front of it and then the 3 at the back. So it'd look like that, a rectangle. Okay, let's have a look at our next question. So question number 10 says, here are the front and side elevations of a solid prism. So we've got the solid prism. We've got the front elevation is this right angle triangle that goes up to the highest point on the left hand side and it goes down to the lowest point on the right hand side. And then we've got the side elevation and we've been asked to draw the plan view of the prism. So if we have a look at it from the front, so it's a right angle triangle and it's going back, and so it's going to be a triangular prism. And we have got this right hand side, that's the side elevation. If you look at this triangular prism from the side, this side or that side, you'd see that side elevation, that rectangle. Okay, and we've been asked to draw the plan view. So the plan view is from above. So if we look down on this shape from above, what would we see? Well, it's going to be a rectangle, because if we think about it, this is the front of the shape and that's the back of the shape perhaps, and if we look down on this triangular prism, it's going to be a rectangle. And in terms of the rectangle, if we consider the front of the shape, it goes 1, 2, 3, 4 across. So the rectangle will go 1, 2, 3, 4 across. And then how far back would it go? Because remember the plan view, you're looking at it from above, so let's see how far back the shape would go. So if this is the front, it goes back 1, 2, 3, 4, 5 squares. So it's going to go back 5 squares. So it goes back 1, 2, 3, 4, 5 squares. And then it goes across 4 and then back 5 again. So it looked like that. So it'd be a rectangle. That's the front. It'd have the highest side on the left hand side and it goes down to the right, and that's it. So that's a triangular prism. And in terms of knowing the dimensions of that rectangle, we use the front of it to see that it goes 4 across, and then we use the side elevation to see that it goes 5 back. So it's going to be a 4 by 5 rectangle like so. And then part B asks us to draw a sketch of the solid shape. Okay, please excuse this sketch. Hope it's okay. So it's going to be a right angle triangle at the front, and it's got the highest point. If we look at it, actually, just look at the front again. It's a front elevation. The front elevation is like so, and it is a prism, so it's going to be a triangular prism. So let's draw that right angle triangle. So we've got that right angle, and it's a triangle, and then it goes backwards like so, and then we just join it up. And that's not too bad, actually. That's the sketch of the solid shape. And that's it. Okay, let's look at our next question. Okay, so question number 11. Question number 11 says, here the front elevation and plan view of a solid shape. So we've got the front elevation and the plan view of a solid shape. So the front elevation is a trapezium and the plan view is a rectangle. And you can see here we've got this flat bit on the top. So that's the flat bit there. And then we've been asked to draw the side elevation. So if we look at this shape from the side, so if we look at it from the side here, what would we see? Well, we'd see it be a rectangle, and it would go 1 across, because as you can see, in terms of going backwards, it goes 1 backwards, so it would just go 1 back. And then in terms of the height would be 2, because if we look at the front elevation, it's got a height of 2. So this would be a rectangle. So if you imagine that shape, it's going to be a rectangle. It's going to be 2 squares up, and it's going to be 1 square back. So let's draw that. It's going to be a 2 by 1 rectangle. It'll look like this. And because the side of the shape goes up in a slant, I'm just going to draw it like that, and that's it. So that would be the side elevation. Okay, and then we're asked to draw a sketch of the solid shape. Let's see if this is as good as the last one. So it's a trapezium on the front, and then it's trapezium, and then it goes back 1 square. So it goes back 1 square, like so. And that's my sketch of the solid shape, like so. And that's the best I can do. It's a trapezium on the front, and it goes back 1 square, and that's it. So just to recap that one, it's a trapezium on the front. The plan view was this rectangle. You can tell from the front that it's got a width of 4. You're not going to see that on the side view. You've got a height of 2, and that's what you'll see on the side view. And it goes back 1. So then it'd be that rectangle that has a height of 2 and a width of 1, and that's it. Okay, let's have a look at our next question, question number 12. So question number 12 says, the front elevation and side elevation of a solid prism are shown below, and we've been asked to draw the plan view of the prism. So if we have a look at this, the front elevation, we've got the shape here. So it looks like an upside down T in a way. And then we've got this side elevation. So in terms of the front elevation, it goes across 4, it goes then across 1, and then 2 there. And then it goes up 2. The total height is 4. In terms of the side elevation, we've got that height of 4, and it goes back 3. So if we were looking down on it out from above, what would we see? Well, we would see a rectangle because it's got the side elevation. It's going back. Remember, it's a prism, so it's the same shape the whole way through. And then it's going to go back 3. So the rectangle is going to go back 3 here. And then in terms of the width of the shape, the width is 4. So it's going to go 4 squares across like so. And it's going to go back 3. So it's going to go back 1, 2, 3, and 1, 2, 3, and across again. Now you may notice we've got this bit sticking up at the top. So you've got these 2 center squares here. Whenever the whole way through the shape, these 2 squares here, 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 and here, here, they're all going to be higher than the ones on the sides. So I'm going to draw those lines there to show that there's a difference in height. So this bit's on the top, and then we've got this bit and this bit that go back as well, and that's it. So it's that upside down T shape going the whole way back, and that's it. So it's 4 squares across and it's 3 squares back like so, and then you've got these 2 lines just to show that the top bits, this bit here, is higher than that bit. And that's it. Okay, let's look at our next question, question number 12. So question number 13 says a solid shape is made using 1 centimeter cubes, and the volume of the shape is 11 centimeters cubes. Well, let's just check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, so there's 11 cubes used, so the volume would be 11 centimeters cubed. And then part A says draw the front elevation of the shape. So we want to draw the front elevation, so what would we see? Well, we would see this little square at the front, like so, that square. And then we would see here we've got our shape here on the right-hand side, this shape here on the right, and then this is on the same level, so we'd see this as well on the left-hand side. It's 2 squares across there. It goes up 2, in 1, up 1, and across 1. So we'd see the square there, and then this shape on the left and this shape on the right. And actually, if you think about it, if you look at the base of it, it's going to go 1, 2, 3, 4, 5 across, with this one here in the center being slightly further forward. So that one will have a little square around it on its own. So let's draw that. So it's got 5 across. So 5 across, 1, 2, 3, 4, 5, and then it goes up and up. I'm just going to draw that one in the center there on its own. And then on this right hand side, we've got these 3 squares. So 1, 2, 3, like so. So that's what you'd see on the right hand side. It's further back, that's why the line's there. And then on the left hand side, we've got these 2 and then those 3. So it would look something like this. It goes up 1, across, up 1, across, and then down. So then you've got that little one in the front on its own. There's nothing above it. No, and then you've got this on the right and that on the left, and that's the front elevation of that solid shape. Okay, and then if we read the rest of the question, it says Jensen wants to add cubes to the solid to make a cuboid. So he's going to add cubes to the solid, so the solid can't be changed and moved around. It's perhaps stuck together with glue, but so it's stuck together and it can't be moved around, but he's going to add cubes to it to make a cuboid. What's the smallest number of cubes that he needs to add? So for instance, he could add lots and lots and lots of them, make a massive cuboid, but that's not what we want to find out. We want to find the lowest number of cuboids that he could add to make this into a cuboid. Now, there's a few different ways you could approach this. One approach is to actually consider, well, if we've got these cubes here and we want to turn this into a cuboid, you need to add a few here in terms of this back row. So in terms of this back row, I'm looking at this back row here where we've got 1, 2, 3, 4, 5 of them going across along the bottom. You could add 2 more here to fill up that row above it, and you could add in 4 more there above there to then fill up that row. And altogether it would have 1, 2, 3, 4, 5, 10, 15. So you'd have 15 there, and if you wanted to have 15 there, you need to add 1, 2, 3, 4, 5, 6. So you need to add 6. Then you could then have, you'd have to have, because you're making it a cuboid, if we've got 15 cubes in this back row, you'd have to have 15 cubes in the middle row. There's 1 there already, so you'd need another 14. And then you'd need to add another 14 cubes onto this one to then have 15 in that row at the front. So then you'd add another 14. And altogether that'll be 6 plus 14 is 20, plus another 14 would be equal to 34. So if you add 34 cubes here, you'd add 2 here to fill up that bit, and then another 4 on top, that would then have 15. And then you have to add another 14 onto that one and another 14 onto that one. So altogether you'd be adding 34. So that's one approach you could do. Another approach is actually visualize that bigger cuboid. So in terms of here, we've got 1, 2, 3 here. So the height of it has to be 3. So the height of the cuboid has to be 3. The length of it, well, it has to be 5 long because we've got 1, 2, 3, 4, 5 going back. And I'd have to have a width of 3. 1, 2, 3. So it'd have to have a width of 3. So if we do 5 times 3 times 3, the length times the width times the height, that's equal to 5 times 3 is 15, times 3 is 45. And we've already got 11, so if we do 45, take away the 11 that are already there, that's equal to 34 as well. So if we add 34 cubes onto these, then you would have a cuboid, which is a 5 by 3 by 3 cuboid. And that's the lowest number you could add on, so 34. So the lowest number of cubes the gentleman need to add to make it a cuboid would be 34. And that's it. Okay, let's look at our next question. So question number 14. So question number 14 says the front elevation of a solid shape is a circle. So the front elevation is a circle. The solid shape is a circle. The side elevation is a rectangle. And the plan view is a rectangle. And we've been asked to say the name of the shape. So if you think about it, the front of it's a circle. And then if you look at it from the side, you're going to get a rectangle. And then if you look at it from the top, you're going to get a rectangle as well. That would be a cylinder. It would be a cylinder that's laying down. So it would be a cylinder. I'm just going to draw it a bit better. So you'd have the shape like that. So you'd have the cylinder. The front of it, if you're looking at it, if it's laying down, it would be a circle. From the side, it would be a rectangle. And from the top, it would be a rectangle as well. So the name of the shape is a cylinder. And that's it. Okay, next, question number 15. So question number 15 says the front elevation of a solid shape is a triangle, the side elevation is a triangle, and the plan view is a circle. So if you look down on it from the top, you're going to get a circle, but then from the side and the front, it's a triangle. That's going to be a cone, because if you've got a cone, if you look at it from the front, you see a triangle, from the side a triangle, and from the top you'd see a circle. So it's going to be a cone. And then finally, question number 16. Question number 16 says we've got this shape. The front elevation of the shape is a triangle. The side elevation is a triangle. And the plan view, if you look down on it, is a square. Name the shape. That's going to be a square-based pyramid. Because if you've got a square-based pyramid, if you look at that from the front, you've got a triangle. From the side, a triangle. And if you look at it down from the top, it's going to be a square. So it's a square-based pyramid. Square-based pyramid. And that's it. And for questions 14, 15 and 16, it can be quite useful to get 3D shapes and to look at them from the front, from the side and from the top and see what the front elevation, the side elevation, the plan view of those various shapes are. And that's it. And that's it. So these have been the video solutions of the Corbettmaths Practice Questions on views and elevations. I really, really hope you found this video useful. If you have found it useful, please like it and please subscribe to the YouTube channel. At the end of the video, I'll put a link that you can click that will help you subscribe to the YouTube channel. So look out for that icon. Also, if you need any extra help on views and elevations, there's a video tutorial on Corbettmaths. If you go to the worksheet section, videos and worksheet section, I'll scroll down to video number 354. There's a dedicated video tutorial there on views and elevations. You can scan this QR code, but again, if you're watching this on YouTube, you can wait to the end of the video and an icon will appear on the screen and you can click that and it'll bring you straight to that video tutorial, or you can click the one that says subscribe. And that's it. So thank you so much for watching. Thank you. Cheers. Bye.